Welcome to the 12th grade Trigonometry, compound angles and double angles. So if you're doing the 12th grade, this is the right video for you. If you're in the 11th grade and the 10th grade, I don't recommend you watching this video. However, someone who's doing the 12th grade and maybe in their college years or university years, I would recommend you to watch this video. For compound angles, I'll be mainly focusing on sine and cos. I won't be doing a tangent because you barely even use it. I don't see any reason why you should know the tangent. It's nothing to worry about. When you have something like this, sine A plus B, what should come to your mind is this rhythm. Sine, cos, cos, sine. That's the rhythm that should immediately come to your mind when you see sine. Sine, cos, cos, sine. Sine, cos, cos, sine. That is the rhythm of how it goes. It's a mnemonic that you should remember that goes hand in hand with these angles. The reason why I'm saying same here, same is this S right here. It means same. It means we should keep the same sign. Don't change the sign. Never ever change the sign. If it's a plus here, you let the plus be as it is. It remains the same. If it's a negative here or a minus, it'll be a minus even here. It doesn't change. For cos, it's cos, cos, sine, sine. Cos, cos, sine, sine. So that's the rhythm that you should remember when you see these compound angles. Now, with cos, remember that this is change. Change meaning if it's a plus here, it'll be a minus here. If it's a minus here, it'll be a plus here. The sign changes. You can determine special angles with compound angles. It also helps out a lot when it comes to reduction. Yeah, it's very helpful when it comes to reduction. Break down a number that is way too high. Let's just say you have a number like 75. Sine 75 degrees. Sine 75 degrees can be compounded to sine 30 degrees plus 45 degrees. Sine 15 can be compounded to 45 degrees minus 30. This right here is compound. So we have 30, we have 45. We can literally write this sine 75 like this and compound it to where we have to write it like this. Sine 30 cos 45 plus cos 30 multiplied by sine 45. Now since 30 and 45 are special angles, there's going to be 1 over 2 sine 30 cos 45 is like a square root of 2 over 2 plus cos 30 now. Cos 30 is square root of 3 over 2 multiplied by sine 45, which is also square root of 2 over 2. So we can already tell that this is going to be square root of 2 over 4 plus square root of 6 over 4. Square root of 2 plus square root of 6 divided by 4. And from here, we can take out a common factor of square root of 2, which is going to be 1 plus square root of 3 divided by 4. That right there is the answer of sine 75. Even if you put it in your calculator most probably is going to give you this answer, or it's going to give you a decimal of 0.9659, etc. But that's the whole point of it. If you like, you can pause the video and you can do sine 15. I think it'll be fun for you. Now let's go to double angles. Double angles are just compound angles but with the same angle. So a double angle is the same thing as sine 2a, meaning it's the same as sine a plus a. It is the same angle that was added together. So they got to this conclusion from what they found with compound angles. What do I mean? Let's write it down. Sine 2 theta. It is the same as sine theta plus theta. This is compound, so it is going to be sine of the first angle multiplied by cos of the second angle plus cos of the first angle multiplied by sine of the second angle. These are exactly the same. It's just that with here, sine was placed on this side and cos was placed on that side. They're exactly the same. So because they're exactly the same, it is equivalent to 2 sine theta dot cos theta. And that's how they got to this conclusion. Same thing with cos 2 theta. They did the same thing that we just did. They also respected the compound angles of cos. It's going to be theta plus theta. It is going to be cos, cos, sine, sine. And since this here is plus, its cos we change, it's going to be minus. That's where the minus comes from. Now because we have cos, cos, they have literally the same angle. We can just put them together and they become a square. And also sine, it also becomes a square. Now from here, we can get to this. From here, we can also get to this. How do we do that? By going back to the trig identities that we did. I think on part 2, that sine squared theta is equivalent to 1 minus cos squared theta. And also cos squared theta is equivalent to 1 minus sine squared theta. So that means wherever we see sine, we can just replace it by this. Wherever we go on to see cos, we can also replace it by this. So where we saw cos, we replaced it by 1 minus sine squared theta. And that's how we got to 1 minus sine squared theta minus sine squared theta. It gave us negative 2 sine squared theta. And that one right there is this one right here. Now, where we got to see sine squared theta, remember when I told you that negative sine squared theta is equivalent to cos squared theta minus 1. A positive cos squared theta plus cos squared theta, which gave us 2 cos squared theta minus 1. You can find this information from part 2, the trig identities explained. Keeping that in mind with double angles, we can also do the same thing here. So since this is the half of this, since this is the half of this, that means for us to get this angle, we just have to divide this one by 2. So for instance, let's just say here it's 40. If it's 40 here, that means it's 20 here, it's 20 here. That means if it's 60 here, that means it's 30 here, it's 30 here, it's 30 degrees here, it's also 30 degrees here. If I have 15 degrees here, that means here I'm going to have 15 divided by 2, 15 divided by 2, which is like 7.5, I think. So keeping that in mind, the same thing could also be done here and here, 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 here. So keeping that in mind, that means if we ever get to have sine 4 theta, that means it's going to be equivalent to 2 sine 2 theta cos 2 theta. And then from here, we could also get other double angles. So that right there is double angles. Well, that's it for this video. The next video will be all about trigonometric diagrams, where we're going to identify the quadrant of where the specific trigonometric ratio is going to be in, and how we're going to move forward from there. I'll be covering from the 10th grade up until the 12th grade, so that video is going to be filled with a lot of information. And I think I'll start doing practice problems after I explain everything in trigonometry as I am doing right now. And don't worry, Even when I do practice problems, I'm still going to be explaining some few things there and there so that it's easy for me to do. It's easy for me to work with. Thank you for watching this video. Please like it. You'll be really helping the channel. Thank you so much for watching this video and have a beautiful day.